Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. And we are still in our efforts digging deeper or diving deeper into the rabbit hole that is finite element. Just to remind you that we are currently in the command that performs the linear elastic analysis, and we are in part 4, solve. And the solving, last video, we finished the initialization. But today we're going to check out the calculate global stiffness matrix. This is once again one of those things that will take time and will take effort. So today we are going to basically outline the different functions that are needed in order for us to calculate the global stiffness matrix. I want to mention that this is part of a video series about the finite element method linked on the top right, and part of its own programming video series also linked on the top right. And as per usual, my dear channel members have access to the entire code. However, if you are not a channel member, then don't worry, because every single line of code will be written in front of you, so you can basically write along and you'll have the exact same code as mine. So with that being said, and without further ado, sit back, relax, and enjoy the show. Let's plan our calculate global stiffness matrix. This is going to be a long shot, by the way. So we are basically going to cycle through every single FEM object I have that can produce a stiffness matrix. So we would have to cycle through the entire FEM bar springs. I think there was an S, right? No, it's object, right? Object dot and also length of object dot fem bar springs, right? There we go. We need to cycle through the entire roster of fem bar springs, and we also need to cycle through the entire roster of fem bar beams, right? Right. And for each one of those dudes, we're gonna do some stuff. We are gonna first of all fish it out. So fem bar equals, I'm going to keep fembar the same name for both because I want to facilitate copy pasting. Object.fembar springs of I. So we fish out the fembar. Now, why did we fish it out? Well, because we're going to do a ton of things. We're going to go fembar.calculate local stiffness matrix. So the fembar must have its ability to calculate its own local stiffness matrix. The fembar also must have the ability to calculate transformation matrix. The fembar must also have the ability to calculate global elemental stiffness matrix. And the fembar must also have the ability to calculate global structural stiffness matrix, which might be a memory drain. This might be a memory drain. Unnecessary memory drain. You can change that if you want. And finally, must possess the ability to initialize its own local equivalent nodal load matrix. And in order for it to initialize its own load matrix, we need to pass in the number of load cases, because the fembar spring doesn't know exactly how many load cases there exist. So I must pass in here the load cases. So I will go here and say length of object dot str load cases. Right. So I think that's that. Now this entire stuff, let me just put some comments here. So here, cycle through the fembar springs and prepare the K. Same thing here, cycle through the fembar beams and prepare the K, the stiffness matrix. And then finally, assemble. So there will be another loop for assembly. So first of all, those are the steps. I'll copy this and paste it for fembar beams. The only change here is here. Okay? Okay. Now once it's done, why am I not adding the stiffness immediately? Because maybe I want to implement a progress bar where one of the progress bars is going to be counting for the calculation of the stiffness, and one of them is going to count for the assembly of the stiffness, maybe. So here, I'll just copy this entire thing. Okay, and basically put an end here, where there's a point here, a wild point appeared. Also, assembly should be on top. And here, I'm gonna basically just add the stiffness. That's all I'm gonna do. So here, I'll fish the fem bar out. I could have added the stiffness here. I kind of feel this is superfluous. But it kind of helps for the progress bar if you want to make a progress bar for the calculation and progress bar for the assembly, maybe. So I'll keep it for now. Now here I'll go for object dot global stiffness matrix, and I'm gonna say this equals object dot global. You cannot simply say plus equals. Doesn't work in MATLAB. So you have to say equals the old object dot global stiffness matrix plus the fem bar dot global stiffness matrix. I don't think it's called that way. There is a ton of errors I need to modify later. First of all, I don't think any one of those exists. And second of all, I think this doesn't exist. I think it's called global structural stiffness matrix. But I'll keep it for now because I'll do the debugging next video, which is gonna happen next day. Because I'm kind of drained today. I'm kind of out of energy. Okay, so regardless of my status, let's copy this entire thing and paste it again. And this time go for fem bar beams, which means this one is going to be called fem bar beams, and the same thing applies. This is the assembly. Now, if I push the run button, it won't work. No doubt about it. Why won't it work? Because we haven't done anything of those functions. Those abilities that I'm asking the fem bar to perform are not there yet. I need to program them here and here. So that is yet another sink that we need, or another rabbit hole that we need to dive in. So we are now, let me just remind you where we are. We are in the perform structural analysis, solve linear elastic, calculate stiffness, and we are now stuck in the calculate stiffness. So yeah, I think we reached another milestone, and I'm gonna stop it here. So with that being said, I want to first of all stop and give a incomplete sized shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support to the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.